Thank you very much, Lance, and welcome everybody. We're going to run today's session as a slightly different webinar. We're going to run it as a panel. So we've got 3 pre-prepared questions, which I'm going to run through the guys on the panel with, and then we're going to go to a Q&A because we really want to talk about what we're really seeing in the market, what's out there, and draw on our experience with discussions with people like yourselves who are actually in there and involved with the problems that are trying to be solved. So I think just to put a bit of scene setting, 5G is driving the need for a new xHaul transport network, and that's going to provide the connectivity between the radio assets and the core network. And both of these, of course, as we all know, can be disaggregated, virtualized, instantiated wherever, whenever required. This transport network can be built by a mobile network operator, but in many cases it can be built by a transport network operator, either another service provider, an MSO, or even a UTelco. Or in most cases, I think it would be a combination, the end-to-end transport network will be a combination of both the mobile network operator and TNOs together, depending on the operator themselves, the geography they've got to cope with, the sort of connectivity that's out there in the network. So during this webinar, we'll explore how operators, the MNOs and TNOs I've mentioned, are looking at constructing the 5G xHaul network to meet these 5G needs. And to do that and help me with this discussion, I'll reintroduce the expert distinguished panel I've got here. We've got Ivan, who's our technical expert in both 5G and IP type solutions, based in our headquarters in Israel. He's a big technical guru on that space. Please call him whenever you need to know anything on those fields. And then we have Sam Lyle and Glenn Yalali, who are your regional experts in the field, really going out and talking to you on a regular basis. So then to move on to the actual panel discussion, Ivan, 5G is the buzzword in our industry, and we hear and see so much material about this. This material varies widely, from material about real issues operators are experiencing today, all the way through to services which are still in the realm of science fiction, the whole idea of autonomous cars, for example. As our technology expert at Ribbon and industry representative on various standards bodies, what do you see as the biggest challenges facing operators today with 5G new radio and the trends over the near future? And how do you see these creating new requirements for the xHaul network?
Okay, very good question. So could you please maybe move to the next slide? The idea of the new types of services which are actually going to appear on the 5G era is high in data volume and require very straight low latency. So the data growth and the propagate capacity of the throughput is on the transportation network is actually coming to the very edge of the transport network itself. So on the way from the edge and from the radio towards the core or to the data centers located on the edge, we will be experiencing some sort of the higher capacity demands and the throughput, and the need of the synchronization for the variety of the radio techniques when you see that the massive MIMO with the multiple layers would be implying the need of, in driving the need of the synchronization distribution towards the radio antennas. And in terms of the densification, when we used to have like a couple of the antennas and stations installed in fields, it would be much more like decreasing the span in between the radio stations and increasing the density. When we had been having like a connectivity density in the 4G, like one station per kilometer, now we would be seeing like a one per couple of square meters or hundreds of square meters. And in the upcoming, like going further, the connectivity and the amount of the stations implemented in fields would be just increasing. So the reliability and latency for the new types of services are a key differentiator from the existing networks, which had been focusing mainly on the delivering of the internet connectivity in terms of the way of delivering the capacity towards the services. And now we see diversification of the services. In some services will be needed to have some very high volume of the data, and some of them would be implying the very specific and very strict SLAs and quality of service, which are going to be implemented in the very harsh conditions and very specific use cases, such as automation and vehicle to something. When you see the connectivity is becoming more ubiquitous, and we see that it is going to change the horizon of the services and the spectrum of the services dramatically. Could you please move to another slide? So from that perspective of the how we see the challenges in the transport network domain in the environment of the connectivity between the radio and to the core or to the edge with virtualized services on the cloud edge, we see that there are three main pillars of our solution in the transport network domain. The first is the transport network, which is based on the multi-access edge equipment with capabilities of the security and synchronization with the various types of the interfaces and the connectivity in the high volume, plus the optical layer and the controlled pillar with the SDM controller, which is controlling the first two and giving the value of the business analytics and the optimizations of the services. Next slide, please. So what we see is that the end-to-end infrastructure is driven by the new types of services, high capacity demands, and evolution of the edge connectivities. If you used to have like a gigabit connectivity in the mobile backhaul, we see that it is coming in a way of the 10, 25, so even 100. And it implies different types of the domains. It could be mid-haul, it could be backhaul, it could be front-haul, meaning that the connectivity from the radio is not the same as it was before. And the different types of the services and different types of the queues are going to be accommodated in the same transport network for 5G era. And going further, it's from the access type of the connectivities to the aggregation and aggregation where the capacity is growing, we see that it is going to be having more dramatic effect on the capacity, moving to the 100 and 400 gigabit interfaces. And the needs for that higher bandwidth is the services which are going to be delivered to the edge. Next slide, please. So speaking of which, from the types of services, what we see, which would be appearing in the first like access and aggregation and even aggregation levels, it would be different types of the QoS schemes and slices. It could be the slices for the mobile backhaul, and could be slices for the mid-haul, and it could be specific characteristics for the front-haul types of the flows. And after UPF, to give the differentiation to the quality of experience based on the SLA characteristics of the each slice and each service, which would be heading to the cloud of the mobile operator, or public cloud, or private cloud, or some local breakouts, to support these diverse types of the services and diverse types of the SLA requirements. We are seeing how the demands for the transport network equipment and transport network devices is changing. Could you please move this slide, next slide? So the majority of the challenges is appearing on the very access on the front-haul and the access and pre-aggregation network elements, and they are driven by the specific growth of the capacity and quality of service. It is also implying aspects of the synchronization, for sure, and very specific and unique demands from the front-haul, what we will be talking about in the next section. Please, could you move next? So one of the aspects of the implementation from the radio perspective, it could be in the way of the ORAN, what they see as a future ready with the types of the connectivities from the access when you have literally no limitation, and going to the mobile backhaul where the service is appearing, and from the first access or first aggregation level, it would be most likely some limitations in the capacity and needs to deliver differentiation of the services. Going to the core, the capacity is growing and the statistical multiplexing gain is growing, and the needs for the specific services in the way of the TTM, or which are requiring some sort of the distinguished flows with the guarantees of the services, would be less and less needed, because the edge, which is on the access, on the edge virtualization node, it would be coming to the local breakouts or the connectivities to the public cloud, or on the private clouds, or some virtualized services, and they would be terminating there, which is shown on the next slide. David, please. What we see, it's a globally like two big types of the services, which is going to be in a network. David? Oh yeah, thank you. Which are actually split into two types of the profiles. One is statistical with the guarantees, when the statistical multiplexing gain is growing closer to the core, and the strict guaranteed types of the traffic, which is relevant on the edge, would be having less relevant going to the core, because the local breakouts and the connectivity to the public cloud, these services will be terminated. So we see that the relevant domain for the isolation for the specific service techniques is on the edge, and in the area of the high level of the aggregation and IP backbone, it's mainly dominated by the high-speed capacity forwarding and a very high gain of the statistical multiplexing. So this is more or less the horizon of the new services from the transport network perspective for the new services and new types of the implementations. Thank you very much.
Thank you, Ivan.
Thank you.
So very interesting there, and now looking at the network that you're talking about, we see you identify a whole long list of new requirements, for the 5G xHaul network, and things like densification, higher capacity, tighter synchronization, new services, all requiring boundaried performance, etc. So Glenn, would you agree these are the sort of requirements that you're seeing in your discussions with the operators you're talking to? And what sort of network are the mobile network operators and the transport network operators looking to create to deliver against these requirements?
Hello, David. Yeah, thank you. I certainly would agree with Ivan's assessment on the requirements, and so we try to put some perspective on that for the transport network with respect to 4G mobile network infrastructure and architecture, and the 5G mobile architecture. So 4G front haul, mid haul shown here, along with the 5G architecture of front haul, mid haul, and back haul. And let's take a sort of a quick summary of the most prevalent transport requirements and conventions in xHaul to before we answer the deployment solutions, because they need to first address these requirements. The most prevailing and biggest changes that we see and that Ivan addressed are in terms of the capacity, both the access side from the RAN components as well as across backhaul and all of the aspects of xHaul. Another major implication is latency requirements, especially in the Fronthaul area, where bounded, in order to support the RAN services, there's bounded latency and jitter requirements that exist in 4G and 5G Fronthaul of 100 to 200 milliseconds of latency and 20 microseconds of jitter. And we also see significant requirements for tighter timing for synchronization of 5G. Many of the sort of initiatives for the new radio are imposing tighter synchronization requirements in Fronthaul and mid-haul, and that imposes Class C requirements for the network elements that perform that timing distribution. From the transport services aspect, 4G Fronthaul and 5G Fronthaul, of course, requires support for transport of CPRI and the eCPRI signals for connecting for interoperability between the radio components. And as Ivan had mentioned, there's a need for service isolation through segmentation, and that we see being required in the backhaul, things like FlexE and other elements to ensure service isolation and meeting SLA requirements. With the common convention for xHaul today has been layer 2, layer 3 MPLS VPN services that can implement it over segment routing. That's a trend that we're seeing in the marketplace, as well as obviously all the Ethernet OAM conventions to ensure troubleshooting and monitoring of the success of the service. Next slide. And so these set of requirements certainly impose significant challenges in xHaul access. And that, as Ivan had noted, most of the challenges with transition to the new 5G radio exist at the access layer. And these challenges, like you had mentioned before, David, they exist for the mobile operator as well as transport operators and neutral hosts that serve the xHaul requirements for the mobile operator. And so we'll show a list of some of these major challenges. Higher capacity, as Ivan had noted, with the presence of a lower price per bit. Of course, that's obvious across all networking applications. The different RAN models that Ivan had pointed out, these deployment models do create a challenge for the mobile operator and transport operators, in that these RAN models can exist not only within the same local area or the same market, but also within a common tower. And so being able to serve the different needs of the different RAN deployment models is a requirement for xHaul access. There's differences between microcell and macrocell. Microcell creating an environment with less space and power introduces particular needs for successful transport. For, of course, 4G Fronthaul, CPRI, it's not simple Ethernet, and we need provisions to ensure the successful transport of CPRI signals for successful RAN. RAN vendor interop, another area that's a major challenge. So the mobile operators are looking at the promise of having different RAN suppliers at either end of their segments, and the transport mechanism in between needs to support that interoperability between different RAN vendors. Multi-service access to monetize various other services that might exist out at a cell tower. The components and the solution that the network needs to support has to provide support for the other access types, such as Ethernet and perhaps even XPON termination out at the cell tower. Timing distribution, which we'd mentioned before, to serve the 10 times higher or more stringent synchronization requirements of 5G is a major challenge, and we have many years of experience in providing sufficient timing and understanding the challenge that mobile operators and transport operators are faced with. And then in order to serve all of the sort of the macro tower overlay of 5G, as well as many new services, fiber optimization is becoming a big challenge, and we're very focused on solutions that ensure the best utilization and optimization of fiber. And then, of course, for multi-tenants and meeting SLAs, we talk about various functions that we have to provide the isolation and monitoring of the multiple segments to ensure meeting of SLA. Next slide, Dave. And so we're very focused on a comprehensive RAN access solution set. Because of the different deployment models that we had referenced before, the emergence of many new services that exist out at the cell tower, we are very focused on ensuring both the CRAN Fronthaul solutions, as well as Metro, Edge, and CSR applications within an access node that then over an Ethernet xHaul transport hubs back at a converged or unified multi-access hub. On the Fronthaul side, of course, we have to support the CPRI radio signals and all the options that exist, eCPRI and Ethernet, and even XPON services that might be required out at the cell tower. And in order to ensure successful and deterministic delivery of the various services, we support extensions to Ethernet, the time-sensitive network extensions that ensure preemptive frame forwarding to ensure express traffic can be delivered within bounded latency and jitter requirements, and interspersing of that express traffic with other services that are not latency and sort of time bounded. Of course, we support PTP 1588v2 with Class C accuracy to ensure the tight synchronization requirements of 5G and other services with open northbound interfaces to support an SDN controlled and lifecycle management system. For multi-service MPLS, we also need to support the services in a 5G environment, the eCPRI and Ethernet and XPON, perhaps even TDM, and as we'll cover in some greater detail how we perform what we call a hybrid slice, which is a blend of both segment routing for isolation as well as channelization of the Ethernet interface as well to guarantee the proper isolation. At the unified multi-access hub, of course, we need to support the sum of all of those features and functionality to serve from a RAN access hub that may see different deployment models and different RAN types from that access hub. So it needs to support a sum of all these services. Next slide, David. All right, so let's do a quick sort of double click on our unified 4G, 5G Fronthaul gateway solution that supports not only the multi-services for CPRI and eCPRI for RAN interconnection, but also layer 2 and layer 3 VPN services out at the cell tower, and even GPON OLT head-end functions. This shows the packetized xHaul solution for Fronthaul, where these various services are supported with a TSN network switch that ensures the interspersing of express traffic for bounded latency and jitter, such as the OAM control and time synchronization, as well as CPRI and eCPRI services and other URLC services that require express traffic delivery with bounded latency and jitter. And then interspersing with other Ethernet services, such as 4G and 5G backhaul and other Ethernet traffic. We through years of install base and a third major release, we've established a complete set of RAN vendor interoperability and certification with all the major suppliers, and through support of the various CPRI options and other aspects of interoperability with the RAN suppliers to ensure that the mobile operator, the transport network for the mobile operator will guarantee interoperability between RAN vendors. And finally, we deliver these services through fiber preservation by ensuring a single fiber to support a 400 gig NNI between the cell tower location and the base station. All right, so a quick summary of sort of snapshot of the solution. Now, regarding the fiber preservation aspect, one of the prevailing conventions for transport operators to in support of mobile operators Fronthaul is typically been a dark fiber service, and we see this as an option for the transport operators to offer a different experience with recurring revenue and fiber preservation. The massive number of fibers required for the radio sites, the 3 sectors per site and 2 fibers per radio, and in 2 radios, 4G and 5G, require a lot of dark fiber. A alternative to this is to offer a lit Fronthaul service, which preserves fiber and offers a higher level of service with recurring revenue. And now that these solutions are proven in the marketplace, mobile operator acceptance for lit Fronthaul service is growing. Next slide. All right. And so that's some deployment models we have for 4G, 5G unified Fronthaul. For DRAN model, access ring in the access layer. We also offer multiple options here as well that are optimized for the various requirements around budget and size and capacity. Both options, which we show here, the O-band option and C-band option, they both operate with simple IP over 8-channel WDM, with one operating in the O-band, where, of course, the signal dispersion and signal degradation is minimized, and so that reduces demand on components and componentry and optics. And so this solution offers very low cost optics over passive WDM with link distances up to 20 kilometer and 100 to 200 gig per wave for a total of 400 gig to 800 gig access ring capacity. For C-band, it's also over passive WDM MUX for cost efficiency, and because the amplification capabilities for C-band, we can extend the distances to 100 kilometers on the link per link, and higher capacity per wave of 100 gig to 400 gig. Both of these solutions provide the aggregation and convergence of multiple services, both the 4G, 5G xHaul services, as well as layer 2, layer 3 VPN services for B2B and XPON OLT. Both provide protection, one at layer 2 Ethernet ring protection, as well as layer 3 protection using IP and MPLS mechanisms. And both support the timing requirements with Class C accuracy. And so this provides 2 different options for for optimizing according to budget and capacity and size. So I hope this was, gives you a sense of some of the deployment options and what we're seeing in the marketplace from service provider demands.
Thank you, Glenn. And quite a lot, I see quite a lot out there in the market, place all the way from the Fronthaul to mid-haul, backhaul, with the timing and everything. So very extensive thought process operators are going through at the moment as they look to move their xHaul network forward. So moving on to one area which we hear a lot of discussion about, we just want to know more about what the operators are thinking, and that's around network slicing. Sam, how do you see network slicing from the 3GPP orchestration perspective, and what is its impact on the transport network?
Yeah, thank you, David. Yeah, slicing is a very significant thing and has a huge impact on the transport network. And it's a little bit of a mystery to some folks sometimes. So one thing I hear very often is, slicing, that's not really anything new. That's just a VPN. And that's sort of a common misconception. I guess I'd like to start there and maybe kind of clear that up a little bit. VPNs, either a layer 2 VPN in the transport network or a layer 3 VPN, those are very, very useful, common, widely deployed things. And their usefulness is primarily because they provide closed user groups. So, Ford Motor Company on one VPN doesn't share traffic with General Motors on another VPN. So it's very good for closed user groups. But fundamentally, the technology is just sort of part of the answer. There's still a lot of resource sharing. The VPNs have very similar behaviors, and the SLAs on those VPNs are statistical in nature. A slice, on the other hand, is actually pretty different. The GSMA defines a slice as a dedicated network delivered on a common platform. So there's not only is there sort of closed user group behavior like you'd expect, but there's a much more stringent isolation of resources. So, if Ford Motor Company bursts their traffic in a conventional VPN, that actually will affect the detailed performance of General Motors. In a slice, that won't be the case. Both Ford and General Motors can kind of burst away, and one traffic will not affect the behavior of the other traffic. So there's much more strict isolation, and there's the capability to manage a slice throughout its life cycle, sort of like it's its own network. So there's a very significant management aspect of slicing that makes it different than just a simple VPN. So let's hit the next slide, David. So there's many reasons why people want to slice the transport network. In order to deliver a full, let's say, 3GPP slicing experience to a mobile customer, you have to slice the RAN, you have to slice the 5G core, and you also have to slice the transport network that interconnects those two things together. So whether you're a mobile operator building your own transport network, or whether you're a transport operator delivering a backhaul service, slicing in that transport network is going to be critical. There's many reasons why people would want to do it. If you're a transport operator, you're providing backhaul services to Verizon and AT&T and T-Mobile and Dish, for example, you want to have all those tenants sort of have their own network experience on your shared backhaul infrastructure. There's lots of new 5G services, some of which are very, very latency sensitive, so you're going to want to give the latency sensitive services their own slice so their performance is protected. If you are building a mobile network to serve different industry verticals, sometimes those verticals will have special needs. And then there's this concept of use case clusters where things like AR and VR will have special requirements, and they appear across a variety of verticals. So there's many, many reasons to deliver slicing in the transport network. And as people evolve their networks to be able to support lots more capacity of 5G, evolving those networks in a way that supports slicing for all these different applications is going to be really important to folks. Let's hit the next slide. Clicking right along here. One of the reasons it's important is not just for the customer will receive a much better user experience, but you as an operator can get paid for that. This is kind of a transport network illustration here. If you're a transport operator and you can provide a deterministic backhaul service to your mobile operator client, you can command a premium for that service. This is actually an analogous example from the world of wireline. This is a U.S. Tier 1 carrier. This is their published guidebook price. And you see these different blue bars are different types of services with roughly the same amount of bandwidth, actually. So the one on the left is the little bitty bar is a layer 2 VPN service. It's kind of best effort. The bar in between is a real-time class of layer 2 VPN service. But the isolated service is the high bar there on the right, and that achieves much more revenue for the same amount of bandwidth than those more bursty kinds of services. Not that highly isolated services are going to be the only types of backhaul services you want to deliver. You'll want to deliver a mix, but having a backhaul network that can't deliver that level of isolation, you're going to be missing out on revenue. Let's hit the next slide, David. David is our master slide forwarder today. So this is not only true for sort of business consumers or business customers. This is also true for just the general consumer population. Consumers have different applications for mobile services, obviously, than enterprises will. Consumers like things like looking at Facebook on the internet, or actually increasingly, even consumers of mobile, they like gaming. So this is a very interesting survey. 60% of ardent gamers, if you have teenagers, you probably have some ardent gamers in your home. 60% of these would have their parents paying 50% more for a high-performing service rather than a lousy service. Lots of gamers would switch connectivity providers in order to get that better kind of experience. And lots of people would even buy a bundle of cloud gaming plus 5G connectivity. So there's a population of folks out there who love gaming. There's actually billions of these people worldwide who would pay more money for a better experience so they can do real-time gaming. They're going to need a transport backhaul network. Even though they have no idea what a transport backhaul network is, they're going to need one of those things in order to deliver that better experience. And they're willing to pay. Next slide. So traditional VPN services, we talked about their sort of closed user group behavior, and I sort of alluded to the fact that a burst of Ford's traffic can actually impact General Motors traffic a little bit. And because of that, if you look at the way transport service SLAs are written, they're written a little more loosey-goosey than I think the next generation of services is going to require. So, because those VPNs can't assure isolation from bursty traffic to one another, and therefore those SLAs are described sort of statistically in nature. They say, yeah, we'll give you good, better, best frame loss, but you often don't see a number attached to it in a lot of SLAs that are out there. Or if you do see a number, it's sort of described statistically. It says, okay, on average, you're going to get a latency that's kind of less than this, but it's not a guaranteed lower bound on latency, for example. Vertical markets, if you're serving those, they're going to increasingly require deterministic services with bounds on loss and latency. And because of this, you're increasingly seeing VPN services being positioned for people who want like less than a gig, kind of the small bandwidth kind of stuff. But as mobile backhaul bandwidth increases, those services are moving from 1 gig to 10 gig, and they're going to be 100 gig kind of in nature very shortly. And a traditional VPN just isn't going to quite cut the mustard. So let's hit the next slide here. Thanks for sticking with us so long on the webinar today, everybody. So let's look at some of the traditional slicing or the transport slicing components that exist beyond just the simple VPN. The VPNs there on the left, you have to have those. Those are very useful for control plane isolation, but there are other tools in your toolkit that you'll need to provide. On the far right, you have to have very robust data plane isolation. So the equipment that you deploy in your transport backhaul network has to support, queuing and so forth. And people talk about hierarchical QoS, and that's important, but that's even not necessarily enough. There are hard slicing technologies in the data plane, one of which is a technology called FlexE. which has been evolved to a technology called G.MTN that provides very rigid isolation between that green pipe, the purple pipe, and the reddish-brown pipe there. So you can have Ford, GM, Chrysler, whoever, on different tunnels, and they absolutely will not interfere with one another. You can also do some things regarding the topology. You can actually create, when you create your slice through the transport network, it's not just that each slice gets a different level of packet performance, which is true, but each slice can actually see a different topology. So there's protocols you need to invoke to do that. But the most important thing of all is actually the network management function that sits above all that and gives you, the operator, the ability to easily define slices, abstract all the hardware complexity that's going on underneath it, and be able to manage the life cycle of those slices as you define them, as you create them, as you bill for them, as you upgrade their bandwidth. You're never going to tear them down. As you upgrade their bandwidth, you got to manage that life cycle. So let's look at that a little bit more on the next slide. So the life cycle of a slice, I guess you could think of it on the lower left there. You create a slice, you assign the resources in the network, you provision those services in the network. Actually, what you want to do before you turn the slice over to the customer, you want to test the performance of that slice, and then you release it to the customer, and then you're in your ongoing assurance and feedback loop where you're constantly monitoring the behavior of the slice. Some of the most sophisticated, let's say SDN-capable management systems out there for slicing, of course we have one of those, but they don't just track performance monitoring the slicing. You can actually track it over time. You don't just do alarms if something bad is happening to your slice. Basically, you can actually track the performance of the slice over time. You can look at trending, and you can actually, in a kind of a closed loop manner, the SDN controller can actually tell the network, hey, I need to beef up the bandwidth on this link. I'll probably need to do that within the next month or so, and really give you a leg up on guaranteeing the performance of these slices throughout their cycle. So if you're, for example, and this is important either if you're a transport operator or a mobile operator building your own network. If you're a transport operator, your tenants are the mobile operators, and you can use this kind of automation technology to set up these multi-tenant slices. You can secure the resources per the slice, whether it's a hard slice like this FlexE capability or a soft slice that's more built around VPN toolkit. And you can sell this as network as a service, and you can deliver a portal to the customer where the customer can actually manage within limits you impose the capabilities of their own slice through the backhaul network. Okay, let's keep moving.
So thank you very much, Sam. And can you stay on, please? And I'll get Ivan and Glenn to join. And we've got a few questions come in. Please feel free to ask some more. Harder questions we can give these guys, the more exciting it will be for everybody. The first question I have is mainly for Glenn, but I'll also to Ivan as well. Is Glenn, you mentioned in your presentation multi-service and multi-access quite a few times. So this is moving towards the idea of single transport network to do service convergence. How important do you think that is in reality in the operators you're talking to? Do you see them actually putting in a single transport network for multiple services, or is this just some sort of marketing blah blah which the various vendors are throwing out there?
No, it's very essential for service providers for monetization of various services that exist out at a tower location. It's an ideal opportunity for converging layer 2, layer 3 VPN services along with residential services through XPON OLT termination and head-end services, along with reliably serving all of the radio signals that the Fronthaul gateway is obligated to perform. And so there's we see that the adoption of that approach being delivered by advanced technologies that ensure the right service characteristics for different access needs. and through elements such as TSN or through networks, appropriately network slicing like Sam just went through. The reality of converged multi-service access in either Fronthaul or backhaul solutions is really a reality, and it's a strong demand that operators have.
Okay, I mean, Ivan, you got anything to add, or do you see similar requirements and needs and direction in the more global markets outside of North America?
Yeah, I think globally it's all going to the new types of the services implemented on the edge, and edge is actually the disruptive domain which is making difference to the services. And that one is driven by the capacity, throughput, and the connectivity, and the new types of the synchronization, and giving differentiation to the services. So yeah.
Okay. Now I've got one. Let me have a look at the. Yeah, I've got one. I think that's probably good for Sam, if you want to start with this one. What are your thoughts on how the existing 4G, LTE advanced networks can be evolved or migrated to get to a 5G type network? And what are the operators you've been talking to saying?
Okay, yeah, thank you, David. That's an interesting question. I think the most obvious thing for operators who are moving either from 4G to LTE advanced or 5G, the most obvious thing they think about is the bandwidth. And they usually think about it starting sort of at the tower locations out on the edge. They have, everybody's got a cell site router that's sitting out there, and we see operator after operator where those cell site routers are just sort of out of gas from a capacity point of view. So they're looking at, they're going to make an upgrade of that hardware at the tower, and then what that happens is there's a ripple effect. There's not just 1 gig or 10 gig coming back from the tower. They're doing the right thing and planning ahead, and there's going to be 100 gig coming back from that tower. And they're sort of looking then at the overall backhaul infrastructure, and in some cases the backhaul infrastructure can sort of handle that increased capacity, and in some cases it can't. So some operators are kind of going through the painful reality right now that they need to actually upgrade that infrastructure. It's a good opportunity for folks long term, if for the mobile operators, because they're going to drive more revenue, but for the transport operators only who are delivering services to those mobile operators, we see a lot of them making investments in new infrastructure. One of the key things then is as you make some sort of new infrastructure investment, it's always difficult to do something new, so do it as few times as possible. Sort of look forward and say, okay, I'm being driven by bandwidth now, so I got to solve that problem, but am I also solving my future synchronization needs at the same time? That's going to be critical. If I'm used to a DRAN model where the RU and the DU and the CU are all together, or the remote radio head and the BBU are together, am I going to evolve that to a CRAN, kind of model? And therefore, if I plunk down a new cell site router there, do I want to be sure that investment can also do Fronthaul? So kind of planning ahead as people feel the pain of the increased bandwidth. That's going to be really important for folks who are on the backhaul side. I guess finally, does that backhaul infrastructure support the capability for network slicing in the future, even if it's not needed right now?
Okay, interesting. Glenn, have you got anything to add? Are you seeing anything to add to that from the operators you're talking to?
Yeah, so we do see one path of being a 5G overlay infrastructure, at least in the access side, but we believe that a converged solution offers a more sort of affordable, it's less capex intensive, and with the abilities to serve both 4G and 5G over unified fronthaul and backhaul infrastructure, allows simple migration. Like Sam said, perhaps you have some equipment needs to be replaced that is serving sort of 4G and 3G one cell tower access of 1 gig with 10 gig. We're seeing a more cost-effective solution of a converged access that preserves investments that they've already made, as well as adding infrastructure to support all of the the advanced requirements in terms of capacity and latency and service isolation. And so we would always welcome any opportunity to show that pricing model with prospects.
Okay, and Ivan, again using your global reach because you've got long arms. Are you seeing the same sort of model in the rest of the world, or is migration working in a different way in different countries depending on where they are with the various mobile technologies?
Essentially, this is dependent on the spectrum acquisition and the auctions, and in those countries who are already started and path their way to the 5G, and they started already doing the upgrades of the transport network because it is not possible to accommodate all the capacity requirements and needs in the existing network capabilities. So these are the countries which are having the luxury of utilizing the spectrum in the 3.5 and as well as the high band like 26, 29 and 24 gigahertz spectrum with the more vast amount of the spectrum. So the application for the fixed wireless access is very intense in terms of the capacity requirements. And yeah, those who already possess this type of the service, they are going to monetization and the investing in the transport network. Yeah.
Okay. Actually, whilst you're there, Ivan, I've got a technical question I didn't actually know the answer to. So I'll be very interested to hear what you have to say. Is in 5G we talk a lot about 25 gigabits per second increments on the frontal interfaces, whereas in Ethernet we hear a lot about 10 gig, 100 gig, etc. Why the difference?
Yeah, the difference is, as I said, there is a requested transmission link, which is relevant for the split on the split 7. And in the 3GPP requirements, which is in the TR 38801, there is a estimation of the Fronthaul throughput with a peak, and it is somewhere in between 10 gigabit and 21, 22 gigabit per second per upload, and per download it is a little bit less. So going to the split 7, it's de facto happened a transition for the 5G. And this is why this range of the capabilities and capacities requirements are unable to be covered with 10 gigabit interface, and 100 gigabit interface, it's kind of the overshooting. So intermediate solutions came across, and 25 gigabit is taking into account the market feasibility and the interfaces with possibilities to do auto negotiation, auto tuning in colored interfaces with the DWDM solutions. And CWDM solutions, it's actually a very good alternative for the connectivity or for the radio stations.
Okay, that's interesting. So I've got one specifically for Sam now, because I think people want to see him with his microphone again. I think they think he's going to break into a song. So Sam, you touched on automation at the back end of your presentation. Would you like to expand on any other areas where you think automation is absolutely key for 5G, and particularly what the operators are thinking in this space?
Yeah, thank you, David. And by the way, if it's anybody's birthday out there, just put something in the questions. I'll sing you a birthday song. Yeah, automation is really key to the whole concept of 5G. We talked about it sort of in the context of the transport network, but it's actually much broader than that. One of the key things about 4G, kind of one of the detriments, if you will, of 4G, is actually on the mobile core. The mobile core is very monolithic. It's centralized, and you backhaul traffic. Actually, in the U.S., you backhaul it halfway across the country to hit the 4G core. when really the traffic doesn't necessarily need to go there. So when they invented 5G, they sort of realized that the world is moving to network function virtualization, and you can take 5G core elements and run them on x86 computers, and you can orchestrate them using cloud-based orchestration techniques. And now you can move pieces of the 5G core around dynamically in an automated fashion. So if you've got latency-sensitive applications, you don't have to backhaul the traffic halfway across the country. You can't do it. You'd be toast. So you actually have the capability now to take what's called the user plane function from the 5G core and in an automated manner distribute that VNF out, in the metro network or even ultimately out towards the access network and deploy it inside what's called a mobile edge computing environment that sits closer to the end customer. So the fact that there's automation going on with the 5G core pieces, there's automation going on in the RAN, that's where the transport network really has to be able to sit there and accommodate the movement of those VNFs, the changing customer requirements, and those kinds of things. So getting back to that slice lifecycle management slide that I showed, all that context of stuff that's going on in the radio world and in the core world really makes that essential then to the transport network can function in the same way.
Okay, I think we've got time for just one last question, as long as you answer it with one soundbite each. We hear a lot about new high-value services needing guaranteed transport network performance. In talking to operators, what do they see as being the key aspect of performance that needs to be guaranteed and what they need to do to their transport network? So, Sam?
Yeah, it varies. We just saw an announcement the other day for 5 millisecond service, for example, for certain advanced applications. You see numbers as low as that, and then you see the number 10 milliseconds for latency is thrown around. Latency tends to be the most important parameter that people talk about.
Glenn?
Yeah, so I would also add ensuring against packet loss and other aspects. And, it's really important for the management system to receive, streaming telemetry and to perform, its analytics and an analysis of those SLAs to support the either the transport operator or mobile operators' needs to understand what their customer experience is. And so that's, Sam mentioned about our SDN, our SDN management solutions. They're very pivotal in understanding and providing displays and information to the user to ensure SLA compliance.
And Ivan, in one sentence?
I see that it is coming in the way of the fulfilling of the services, in the way of the differentiated services model. What we see that is going to happen and start happening in this standalone 5G. And this would be the continuation of the path of the certification and standardization, I think.
Thank you very much, and thank you everyone for staying with the webinar. It's been quite exciting for me anyway, and I think for the other panelists. We welcome to talk to you more. Sam and Glenn are based in the US and would be happy to come and talk to you directly. Ivan would also be very happy to leave Israel at some point and come and talk to you, but he can also talk to you remotely. So thank you very much, everybody, and the slides will be sent out over the next week or so. Thank you very much.
Thank you. Thanks, everyone. Take care.